Welcome to section 7.2, day 1, division properties of exponents. Today's objectives are to divide powers with the same base and then to raise a quotient to a power. So today we're going to be dividing powers with the same base. To divide powers with the same base, subtract the exponents. Remember when we multiplied, we added them. Well, when we divide, when we have a quotient, we will subtract them. We take the upper exponent minus the lower exponent. So the exponent in the numerator minus the exponent in the denominator. And a cannot equal 0 because we cannot divide by 0. And m and p are integers. So here we're going to simplify. We have y to the 5th over y to the 4th. When we are doing this at this point, I want to see that you are actually subtracting them as we learn how to do this. So we have y to the 5 minus 4, which is just y to the 1st, which is just y. If we have an exponent of 1, we do not need to write the exponent. So we have g to the 3rd, h to the 5th divided by g h to the squared. So we take g, we have the exponent of 3 minus 1 times h, and we have 5 minus 2. And when we do this, we get g squared h cubed. 5 minus 2 is 3. So there is our final simplified form. For number 3, we have x cubed y to the 4th over x squared y. And we're going to do the same thing. We take the upper exponent minus the lower for the x, and the upper exponent minus the lower for the y. And we have 3 minus 2, which is 1. We have x to the 1st, which is just x. Y to the 4 minus 1, which is y to the 3rd. So these are some simple ones, and all we're doing is subtracting the exponents. All right, now we have raising a quotient to a power. To raise a quotient to a power, raise the numerator and the denominator, and then simplify. So if we have a over b to the mth power, we would take the m and distribute it to both the numerator and the denominator. So we're going to bring the exponent to the a and to the b, and then we get a to the m over b to the m. And now the thing here it says is this works for any real number a. B again cannot be 0 because we cannot divide by 0, and m is an integer. So our first one, we have 2 over 3 all raised to the 3rd power. We are going to bring the 3 to both the 2 and the 3 in the denominator. So we get 2 cubed over 3 cubed. And again, I want to see that you're actually distributing and bringing this power into both the numerator and denominator, like I've shown. And if you take 2 to the 3rd power, you get 8. 3 to the 3rd power is 27. And my answer in fraction form is 8/27. What I do not want you doing, I do not want you sitting on your calculator typing in 2/3 and taking it to the 3rd power and getting me a decimal. I want to see the work, and I want to see the fractions. For number 2, we have 2x cubed over y all squared. So we need to bring this power into everything on the inside. So we're going to bring it to the numerator. We're going to bring it to the denominator. I'm going to show you all the steps that you can do, and then we'll talk about what I need to see. So we have 2x cubed all squared, because we bring the 2 into the top, and we have y squared. What we did the other day was multiplication with powers. We have a product in the powers. We bring this 2 into both. We'd have 2 squared. We multiply 3 times 2 to get x to the 6th over y squared. And we get 4x to the 6th y squared in the denominator. And that is my final solution. Now, if you brought it all the way in right away to the 2 and you had 2 squared and you went right to this point right here, I would be okay with that. Okay, just make sure you bring it to every piece inside. And notice we have a product in the numerator. We don't have any addition or subtraction. If we would have addition or subtraction, it's a totally different thing. You will not see any addition or subtraction today when we're doing this. Next, what we need to do is talk about negative and 0 exponents. Since we're doing division, we're subtracting exponents. You might run into some 0 exponents or some negative exponents. So the 0 exponent property. Any non-zero number raised to the power of 0 is 1. No matter what you do. So a to the 0 is 1, 15 to the 0 is 1, b over c to the 0 is 1. Anything raised to the 0 power becomes 1. Then we have the negative exponent property. For any non-zero number a and any integer n, so we have a to the negative nth power, it becomes basically the reciprocal. We flip our term and we have 1 over a to the n. When we move the power, we change the sign. So a to the negative n is like being a to the negative n over 1. So what we can do with this is we basically take the reciprocal, and when we take the reciprocal, we change that negative exponent to a positive exponent. So if we have 1 over a to the negative n, again, we take the reciprocal, and when we do that, we change the sign on the exponent. The biggest thing you need to remember when we have negative exponents, it is telling you to move it. If it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. So why does the exponent of 0 always become 1? Well, if we did some basic problems here, I can show you why. If we have a to the 5th over a to the 5th, and we subtracted the exponents, we had a to the 5 minus 5, we would get a to the 0. And if we just simplified this, a to the 5th over a to the 5th, you would probably all agree it's 1. It's the same idea if I have 2 squared over 2 squared. If I take my exponents and subtract them, I have 2 to the 2 minus 2, which is 2 to the 0, which is, again, 1. And if you took 2 squared, you'd get 4 over 4. And you should all agree that 4 over 4 is 1. This is why when we have an exponent of 0, it turns whatever's in the parentheses in the case of the b over c, or anything raised to the 0 power, becomes 1. And this is why. So here are some examples of negative exponents and exponents that might go to 0. So first, let's take 2 to the negative 4th. And what we do first with the negative exponent is we move it. Remember, 2 to the negative 4th is like being 2 to the negative 4th over 1. We flip it, we move the 2 to the negative 4th to the denominator, and we get 1 over 2 to the 4th. And again, if we take 2 to the 4th on your calculator, if you need to, it is 16. So we get 1 over 16. If we have 1 over j to the negative 4th power, again, we are going to move it. Since the negative exponent's in the denominator, we are going to move it to the numerator, and we get j to the 4th. For number 3, we have n to the negative 5th, p to the 4th, all over r to the negative 2nd. We are going to move our negative exponents. We are also going to keep our things in alphabetical order in our numerator and denominator. So we have n to the negative 5th. It must move to the denominator. So it's going to be n to the 5th. Working along with our numerator, we have p to the 4th. It's a positive exponent. It stays put. We still have in our denominator r to the negative 2nd. We want to move that from the denominator to the numerator, and we get r squared in the numerator now. So we have p to the 4th, r squared, all over n to the 5th. And we no longer have any negative exponents. When we do simplification and we have negative exponents, we must get rid of them. Our final answers cannot have negative exponents in them when we're doing these simplifications. So make sure when your final answers are done that you do not have any negative exponents. If you have a negative exponent, you must move it. All right, next one, number 4. We have v to the negative 3rd, wx squared, all over wy to the negative 6th. So again, I'm going to work my way across the numerator first and see what I need to do. If you notice, first thing we have is a v to the negative 3rd. There are no v's in the denominator, so I can go ahead and move it to the denominator. So now we have v cubed down below. I've taken care of it. We have a w in the numerator, we have a w in the denominator. This would be to the first power, this is to the first power. Or you can think about it as we have w over w. They cancel each other out. If they were different powers, we would subtract the exponents, but they have the same power, so we can actually just cancel them out. The next term we have in the numerator is x squared. It has a positive exponent, so it stays put. Now in the denominator, we still have y to the negative sixth. We must move it from the denominator to the numerator to get that positive exponent. So we have y to the sixth moving top. And this is my simplified version. There are no longer any negative exponents. We have x squared, y to the sixth, all over v cubed. That is all for section 7.2, day 1. Today we are doing division properties of exponents. We looked at some negative exponents and zero property of exponents. Thank you for watching and have a nice day.